Hello. Today I am going to discuss an ETL scenario. If you are working with data warehousing, you may know that ETL is one of the challenging tasks in data warehousing. Number one, reason for that is number one, it depends on case to case. ETL deals with source systems, operational systems, where they define them in their own formats, where you have minimum or less control over it. And also, you have to have deal with heterogeneous data sources, meaning different types of data sources. It can be text files, it can be relational databases, it can be NoSQL databases, it can be web services, etc., etc. Once you extract it, most likely you have to do a transformation that should match with your data warehouse fact tables and dimensions. These are no means easy task. In this two episodes, I'm going to discuss about a specific case, a real world case on ETL, how are we going to plan it and how the real implementation of this particular scenario. So let's move into the specific case scenario now. Right. So I have taken this sample text file. I'll be using a Microsoft sample database of AdventureWorks DW. AdventureWorks is the mythical cycle selling company. AdventureWorks DW is that their data warehouse for that particular AdventureWorks operational database. Now, what you can see is a standard order details that you get. Now, remember, even though I have listed out two orders here, in a standard or typical environment, you will get 1,000 or 100,000 orders per day. So it's not a very simple file like this. It can be a very large file as well. So let me first explain what this text file is. In an ETL, when you are starting the ETL, first thing you need to understand is what this data is. Sometimes you may want to ignore them. Sometimes you want to do some transformations. You may not be able to use it as it is. So let's see. First and foremost, you need to look at what this text data file is. To start with, you can see it has the company name and the order details, the date for that date that was generated. And then you can see a little bit tricky text file. If you look at this one, let's see if this is your order number 1125, you can see it has different properties depending on the order type. If I explain what this is the order number, this is the record type. Typically, it stands for header. It can change from environment to environment, but it stands for header. Then, this is the order date. This is the customer code. This is the employee code. This is the expire date for the order. In case you want to return your items, you have to return the items before this date. Then you have D records, that is detail records. This is the product code. Now you know in an order, there can be multiple line items. When I'm buying order, there can be multiple items that I am buying. So those lines represented in the D record. This is the product code, quantity, unit price, and the discount percentage. So here you will see the product code is CN6137. Unit price, the quantity is 12. Unit price is 45. Discount is 1%. And again, you have a T record, detailed T record as well. So in the T record, you have the currency, USD. Then they have promotion. This is the promotion which they attract this particular sale, Mountain Tire sale. Southwest is the location, and this is the organization. So if I go through, let me go through the, so if I look at this particular data warehouse, you will see some, you can identify measures and dimensions. Now in a data warehouse, first thing you need to identify is what is the event. So in this event, its event is the order generation, order creation. In this order creation event, you will see you have to identify your measures. So now let's identify measures. So by just looking at the existing measures, you can see one is quantity, unit price, discount, percentage. These are clearly can be taken from the text file. However, in data warehousing, we do not stick to those measures only. Now, if you look at the quantity and unit price, we know that the gross amount will be calculated from the quantity into unit price by multiplying quantity into unit price. When you have the discount is the amount into that particular percentage. So our net amount is the total gross amount minus the discount amount. So when it comes to data warehousing, we don't let end users to do this calculation on the fly. We always calculate them and store it in the data warehouse so that they can be used. They can access these measures much easier. Remember, your data warehouse is accessed by your people who take strategical decisions. So I don't think they have time, and they won't have time for them to calculate these things. So it is up to you, designer of the data warehouse, to calculate these and store in the data warehouse itself so that they can access this much easier. So we will extend these measures into some other derived measures. So we will have gross amount, which will be quantity into unit price. Then we will have the discount amount, which is gross amount into the discount percentage divided by 100. Then we have the net amount, which is gross amount minus discount amount. Right? So our measures are done. So we will, even though our text file directly, it shows 3 measures, we have another 3 derived measures called gross amount, discount amount, and the net amount. You can see how we can extend our measures into another level of analysis. So we are done with the measures. Next is to identify the dimensions. That is also pretty much easy. Now remember, when we are designing a data warehouse, we are not looking at simply this particular record and designing it. We are looking at the big picture, what type of analysis that they do, and then you confirm your dimensions. But for this particular example, I will see what are the dimensions we can use. So when you are starting with, we will have the customer dimension. So then we will have the customer dimension, then the employee dimension, then we have the product dimension, then we will have in the T record, we have the currency dimension, then we have the promotion dimension, location dimension, I think geography dimension, and the organization dimension. So we will have a promotion dimension, location dimension, let's say for the moment it's location dimension, and last but not least, organization dimension. So have we covered with all the dimensions? Not really. What about the date? So here we have two dates, order date and the order expire date. Now, with this, in data warehousing, date is a separate special dimension. Unlike in operational systems, we analyze our data through a lot of date parameters, such as whether it's a weekend sales, whether it's a sales on a holiday sales, end of the month. So we do a lot of data analysis with dates. If you want to look at the details about date dimension, there is a video done on this. It's available in the data warehouse short the video list. So you can look at that. Also, I will include that is in the description as well. So we will have the date dimension. Now you might ask, but we have two dates. One is order date, other one is expire date. Now it depends on tools. Some tools are capable of handling multiple dates with a single date dimension, which is called role-playing dimension. When you are connected with the order date, your date dimension will become order date dimension. When the same date is connected with the expire date, that will become expire date dimension. That's called role-based role-playing dimensions. But here let's stick into the role-playing dimension, which is the most easiest and common one. If not, you have to have two different dimensions, but let's stick to the date dimensions. Now, what I want to tell you is, number one, for this particular simple data set, you have 6 measures and 7, 8, 1, 2, 3, 4, 5, 6, 7, 8 dimensions. Now, then you might ask whether this is an arbitrary example or this is the real world example. Yes, this is a real world example. In relational world, when you are working with relational databases, yes, you will have three separate tables for this: order header, order detail, and order total. However, most of the data, operational data, can be in different format. In old COBOL era, data is stored, this type of data is stored in a one single format. One file can contain different types of data. They have something called redefined keywords. From that, they redefine the header, detail, and total. In modern days, if you look at document databases such as MongoDB, one of the capabilities of MongoDB is having this type of data. They have a design pattern for this, which is inheritance design pattern. You can see you have the order. If you go to the OOP concepts, we have the order object. It can be abstract class. From that abstract class, it will have the order number only. And then you will have three inherited classes: order header, order detail, and the order total. They have their own properties. And finally, it will become a one document that will be saved in the MongoDB. Now you can see you will end up with this type of data sources. So when you're dealing with ETLs, you have to expect this type of different data that you are receiving from the operational systems. That is a typically a challenge for a day ETL developer. Right. So we have not yet done with the fact table. Before that, let's go to the data warehouse and see whether where are these dimensions. So I'm using, as I said, I'm using AdventureWorks DW 2022. And then you can see the DIM currency table is there. So which has all the currencies. And we have the DIM customer, where we have the customer key here, and with the customer alternate key, customer code, and the customer key here. Now, what's the customer key? In data warehousing, we have a separate, we are introducing a separate internal key, which is called surrogate key. Again, there is a separate video on this. I will share that video in the description list as well. So surrogate key, we have many reasons to include a surrogate key. Now one of them is if you have a customer key like this, which is a string characters, if you are joining them with the string characters, there will be a performance impact. Remember, in data warehousing, you are dealing with large volume of data. What type of analysis you do? Last month versus this month. Last year versus this month. So when you are doing that, you will have a large volume of data. So it's always better to have joins using integer columns. So that's one reason. There are many other reasons as well. So we include surrogate keys. So typically we will see surrogate keys in almost all the dimension tables. Then the dim date. So you can see the date key is there. Typically, if you look at the other surrogate keys, they are just a number. It doesn't have any meaning. But when it comes to date dimension, it's a special dimension. As I said before, typically we introduce the date surrogate key as YYYY, MMDD format. Now there's a reason for that. That is to improve the partitioning. Again, another video is available, which you can see in the description. In the description. So apart from the date key, you can see a lot of dates are also, there are different types of date properties are also here. That is done. and then the employee table. Now, this is little important thing. So this is the employee number, but interestingly, this is type 2 SCD dimension. What is type 2? Type 2 means you keep the historical aspects of the data. So if you want the employee, that employee you should take from the current employee. You should, because this is the current employee and he has a previous record for this. Since we are looking at the current, we want the current surrogate key, we always want to search for the status current. So that's about the employee. Location, they have specified as a geography dimension. So which is the geography dimension? We have the city, I guess. We have the city. From the city, we need to get the geography key, right? Another one important dimension, product dimension. We have the product alternate key, and the surrogate key is also in the dimension there. And then this is the promotion dimension. This is the promotion name. And then we have the promotion key, surrogate key as well. Okay, I missed the organization part. So then we have the organization as well. We have the organization name where we need the organization key as well. So have we covered all the dimensions? Currency, customer, date, employee, geography, organization, product, promotion are covered. So we have 8 dimensions which we listed here. Now, in this particular scenario, we assume that all dimensions are updated. In a typical environment, first you have to update the dimensions, then you have to update the fact table. So here we assume dimensions updates I have done, it is completed. Right. Now our next step is define our fact table. We have done with the measures. So let's extend this with the relevant surrogate key. So we will have the customer SK. If you want, you can say customer key, employee key, product key, currency key, promotion key, location key, organization key, and then for date, remember we have 2 surrogate keys for that. That is order date key, order expire date key. Apart from this, it is always better to have some audit columns such as order number, record, inserted date. So this is our completed fact table design. Completed fact table design. In the next video, we will look at how are we going to translate this data, which is our source data, into this fact table. So let's discuss that in the next video.